Okay, I do want to preface this part of our worksheet with if all we had to do was graph an ellipse, it's really quite simple. We can find basically the vertices in both directions. We can figure out where the center is, and then we can call it a day. We are asked to find some very specific points in this class. So this is stuff that you're absolutely going to see on your final. So you're going to be asked to find these points on different types of graphs. So unfortunately, we do have to go a bit deeper here. Okay, so a couple of things. First of all, we're very specifically for topic two going to look at the equation of an ellipse with a center at the origin. Okay, so we're going to be centered at, whoops, the origin. Okay. And this basically just means no transformations. We're not really stretching, compressing, shifting, none of that weird stuff. Okay. So this is just going to be centered at the origin, pretty easy. Okay. So what I want you to understand here is we let A always be the distance from the center to the major vertices. So the major vertices are like, we don't really call them major vertices. We usually just call them the vertices, but they're the ones that are on the same axis as the foci. Okay. So we have to be really careful about what we call A and B. And then B is always the distance from the center to the minor vertices. So A is always, in these equations, we always have A is going to be the bigger of the two. So we say, um, it ends up that A ends up bigger than B. Okay. So we have to be really careful. And if we scroll up just a little bit, we had this picture right here, this one that's on the right. We always say that the distance A, we've labeled it A. A is the distance from the center to a major vertex, and B is the distance from the center to the minor vertex. B is always going to be the shorter of the two, and that should make sense in our head because remember, we have this Pythagorean relationship, and A is the hypotenuse of these little right triangles that we form, so A has to be the bigger of the two, okay? And it kind of depends on where A is. If A is the value under X, so meaning the number underneath X is the bigger, then we have an ellipse doing this. If the bigger value is under the Y, so if the number under the Y is the bigger one, so A is under Y, we have an ellipse doing this. Okay. And this does matter because one of the things we have to find is our major axis. So is our major axis, oh, biscuits. So is our major axis some kind of like horizontal value, or is our major axis some kind of like vertical situation? Okay. So we do have to be really careful about understanding that A has to be the bigger of the two. And depending on what A is underneath tells us kind of like what our axis is. Like, is the major axis the horizontal or is the major axis the vertical? Okay. Now, when it comes to figuring out the major and minor axis, when you have an ellipse that's centered at the origin, the major and minor axes are going to be the x and the y axis, okay? And then the foci are always going to be pretty easy to find. They're going to be points on the x or the y axis. So what we do is we have to calculate what c is. Now remember, we have this Pythagorean relationship. We'll be given values for a and b. We can use this Pythagorean relationship right here to figure out what c is. So we'll have to find c, and then we just basically go up or down on the y-axis, or we go left or right on the y-axis from the center, C units, okay? Now the vertices are always going to be from the center plus or minus A units, left and right or up and down depending, okay? And then B, we don't worry about it quite as much. I'm going to worry about it. I'm going to specifically do the vertices and then the co-vertices or the minor vertices, okay? So just know that the minor vertices are going to have plus or minus B, okay? So I'm going to go, whoops, I'm going to go over here and say minor vertices, which are also called co-vertices. They're going to be 0 plus or minus b, or plus or minus b comma 0, depending on where that major axis is. And then just please, you cannot forget the Pythagorean relation is a little bit different than what we're used to, okay? A is now the hypotenuse, B and C are now the legs. Okay, so you got to kind of understand all of this information and how it plays in together. I think these ordered pairs for the foci and the vertices, it makes a bit more sense when you have an actual example. Okay, so let's dive in. So example one here says graph the following, label the major and minor axes, the foci, the vertices, and the center. So again, if all we had to do was graph this, piece of cake. Okay, so what I'm going to do is I'm going to pretend for now that we're just graphing this so you can get a general idea of how these numbers work, and then we're going to go back and we're going to do like the grunt work. Okay, so what's happening here is we have x squared over 16 plus y squared over 9. So what we know is that a is always the bigger of the two. So a squared is 16, which tells me that a is plus or minus 4. I forgot my plus or minus. We know that b squared is 9. Remember, a is the bigger of the two denominators, b is the smaller of the two denominators. So that tells me that b is plus or minus 3. Okay, so we have to be really cautious of like what is the major axis, what is the minor axis. Well, we've got the bigger number under x, so that tells me that the major axis is going to be the x-axis. Okay, so the major axis is the actual x-axis itself. So we can easily plot the vertices. All you have to have is A and B. So if the origin is at 0, 0, so that's our center. Okay, if the origin is at 0, 0, bless my heart. If the center is at the origin, okay, all we have to do is go to the left and to the right. So we would take 0 plus or minus A, and then 0 is going to be the y coordinate. So we would get 0 plus or minus 4. So that gives us the ordered pairs, -4, 0, and 4, 0. So you have your major vertices there. Now, the minor vertices would be kind of the opposite. The minor vertices are going to impact y in this case, not x. So we would say they're going to be 0, and then comma 0 plus or minus b. So we would get 0, comma 0 plus or minus 3. So we get 0, comma -3 and 0, comma 3. So from the origin, we go up 3 and then down 3. All right. And so again, if that's all we had to do, we're done. We've got a pretty, it's a chubby little ellipse. I'm so terrible at drawing these. And I end up making it worse. Like the more I try to fix it, the worse it gets. But let's pretend that's it, okay? So if that's all we had to do, we'd be good. But we have to find a bit more, okay? So let's go ahead and just label what we do know. We know the center. So we know the center is at the origin. We know the major axis is the x-axis, which makes the minor axis the y-axis. So we've labeled the two axes. We know the center. We also know the vertices, okay? We have -4, 0. We have 4, 0. Those are your major vertices. And then your minor vertices or your co-vertices would be these on the minor axis. So this would be 0, 3. This would be 0, -3. What we're missing are the foci, okay? And the foci we have to do some work for, okay? So do I have room? I haven't given myself a load of room here, so I'm going to scoot down here for the foci. Okay, so the foci. The first thing we need is we need C, okay? And you have to remember our Pythagorean relation. So our Pythagorean, I said that funny, Pythagorean relation is that a squared equals b squared plus c squared. Well, we need to find out what c is. So we want to get c alone. So we could say, okay, well then c squared equals, we would have to subtract b squared from both sides. Let me actually show you that. So we would subtract b squared from both sides. And that tells me c squared is a squared minus b squared. So if I wanted to get c, I just take the square root of both sides. And I would get that c is the square root of a squared minus b squared. Well, we already know what a squared is. That was the denominator under x. And we know what b squared is. That was the denominator under y. So we can say, okay, we know a squared is 16. We know b squared is 9. So it's going to be really easy to figure out what c is. We take the square root of a squared, which is 16, minus b squared, which is 9. So we get that c is the square root of 7. And I don't remember off the top of my head what the square root of 7 is. I don't suspect anybody does. So the square root of 7 is about 2.6. So we'll say approximately 2.6. Okay. So that is the value for c. All right. So we know that from the center to either of the focus points is going to be c units away. Well, we know that c is plus or minus the square root of 7, so it's plus or minus 2.6. So if my origin is 0, 0, that's my origin, right? To go left or to go right, that's going to impact my x's. So to get the foci, I'm going to take 0 plus or minus c. That's going to be my x coordinate, and then my y coordinate is just going to stay the same. It's just going to stay 0. So that's going to give me, I'm still out of room. I don't know how I've done this. So I'm going to get the ordered pairs, negative 2.6 comma 0 and positive 2.6 comma 0. So we're going to have to kind of eyeball those, but that's okay. So from the origin, we want to go back 2.6. So this is like 2.5 a little bit further, and then 2.5 a little bit further. So that is foci 1. Focus 1 is probably better, and then focus 2. All right, so let's go through here and label some stuff. I'm going to go ahead and put the focus points up here. So I guess I should say foci. Please forgive me if I say focus when I mean foci or foci when I mean focus. You get the gist. So the foci are negative 2.6 comma 0, positive 2.6 comma 0. So those are the foci. Let's change colors. Let's go to yellow. So those are the foci. Okay, the vertices are negative 4 comma 0, 4 comma 0. And then the co-vertices, or the minor vertices, you'll definitely see it called minor vertices as well. Those are 0, negative 3, and 0, 3. So, ta-da! So again, if all we had to do was graph this puppy, that was easy. It was finding all those individual points that's a little bit harder. So there you have it. That is an ellipse. It's not a very well drawn ellipse, but it's an ellipse. I've told you many times I'm a lot of things. I'm not an artist, okay? Just please be very careful with the Pythagorean relationship, okay? You have to be very, very careful with what A is, okay? A is the hypotenuse. It's the longest side, okay? So let's go ahead and look at B. B is going to have the exact same instructions. Let me see if I can squish this. There we go. So in part B, we have 4x squared plus 25y squared equals 100. So what you have to understand is the general standard form of an ellipse is always going to be something equal to 1. Okay, well, we definitely don't have equal to 1. So what in the world would we do to get this set equal to 1? Well, we would just divide all parts by 100, right? So if I can divide this right-hand side by 100, I get my 1. Okay, but I then have to divide the other two parts as well. Okay, so this is really going to be, well, 4x squared divided by 100, 4 will go into 125 times. So we get x squared over 25. For 25y squared over 100, 25 will go into 104 times. So we get y squared over 4. And then 100 over 100 is the 1. So we have to do a little bit of work to get this into that kind of standard form where we know how to work with it, okay? I do also want to take a moment. I probably should have mentioned this earlier. If A and B were exactly the same, you would end up with a circle. Okay, so if we kind of go back up here to like all of this junk that we had, please do make note. Note, if A equals B, we have a circle. So that's kind of a big clue that you have an ellipse, is when you have a situation that you have a format like this and A and B aren't the same. You know you're dealing with an ellipse then. Okay, so let's think about this. Again, let's just pretend the direction said, hey, graph this. Well, we have to figure out the major and the minor axis, okay? So when you're centered at the origin, you know the major and minor axis are going to be the x and the y axis. You just have to differentiate between the two. So what is A? Well, A is the distance from the center to the major vertices, okay? So A has to be the biggest value. So a is, or let's say a squared is 25. Therefore, a is the square root of 25, which would be plus or minus 5. Okay? Now, b is going to be the smaller of these two values. Okay? So b squared is going to be the smaller denominator. So b squared is 4, which tells me that b is the square root of 4, so it's plus or minus 2. Okay, so really all we have to do is from the origin go left and right 5, up and down 2. So up, down, left and right. Our center is the origin, and we can pretty well sketch. God bless, that's even worse than the first one. It's like you think it can't get worse, and surely it does. Okay, that's not terrible. All right. So if all we had to do was sketch it, we would be done. But we have to find very specific points for the vertices. And sometimes if you can do this just bare bones sketch, like what I did here, sometimes finding those vertices really isn't that bad. Okay. So let's see here. We want to make note of the major and the minor axes. Since the larger denominator was under the x, I think I started that chat and then got sidetracked. Since the larger denominator is under the x, that tells me the major axis is going to be along the x-axis. It's going to be the horizontal. So we're going to go ahead and say the major axis is going to be the x-axis, and you can see that here. So let's label this. This is the major axis. This is the minor axis. We don't really have to do a lot to label the center. Like we know the center because of the format here. We don't have x plus or minus. We don't have y plus or minus. There's no transformations here. So the center is just the origin. Okay. Now I'm going to do the vertices first. So let's do the major vertices. All right. So with the major vertices, because we're kind of oblong horizontally, the major vertices are going to be along the x-axis. So we want to take whatever x is, which in this case is 0. We want to add and subtract a, and then y is going to stay the same. Okay, so the y value doesn't change, but the x's do. So we're going to get 0 plus or minus 5, comma 0. So that's going to give me vertices of -5, 0, and 5, 0. So we can go ahead and label those. All right, now we want co-vertices, and I've said this before, but I'm going to say it again. Co-vertices will also be called minor vertices. Okay, the minor vertices, they're going to be the vertices that are running along the axis that is perpendicular to the major axis. Okay, so that's why they're called minor vertices sometimes. So these are going to impact the y's in this particular ellipse. All right, so the 0 on the x is going to stay the same. The 0 on the y is going to change. So we want to go 0 plus or minus whatever your b value is. So that's going to be 0, comma, 0 plus or minus 2. So our co-vertices are going to be 0, comma, -2 and 0, comma, 2. So we have 0, comma, 2. You scroll down just a tiny bit. And then we have 0, comma, -2. Okay, so we've done a whole bunch so far. Last up, foci. Okay, so I'm going to give myself a little room down at the bottom again. We have to remember that when we're dealing with an ellipse, the Pythagorean relationship is not the same as the Pythagorean theorem that we're used to. So please remember the Pythagorean relationship is a squared equals b squared plus c squared. Okay, so we've already done kind of the work on the previous example. What we need to know is if we're looking for c, we subtract b squared from both sides. So we get c squared equals a squared minus b squared. And then to get c, we just take the square root of both sides. And remember, a squared and b squared are the values given to you in the actual equation, okay? So we know that a squared was 25, and we know that b squared was 4, okay? So when we go to find c, c is going to be the square root of a squared, which is 25, minus b squared, which is 4. So c is the square root of 21 plus or minus, which is approximately the square root of 21 is, let's go 4.6, okay? So this is approximately 4.6. Now remember, Your foci run along the major axis, and they're pretty close to your major vertices. They're just sort of inside those curves. So what we're going to do when we go to get the foci, we need to make note that C equals plus or minus 4.6. Okay, since our major axis is the x-axis, these foci are going to impact our x coordinates from the center. So we're going to go x plus or minus c comma 0. So x coordinate is 0. So this is going to be 0 plus or minus 4.6 comma 0. So the two foci are negative 4.6 comma 0 and positive 4.6 comma 0. So 4.6 is right about there, right about there. So that, let me do them in green so they're a little bit easier to see. So those are the two foci. I'm going to call them foci 1, foci 2. There's not really enough room to label the ordered pairs in there, so you got your ordered pairs up here. So let's do some highlighting. We've got covertices. We've got major vertices, we have foci, we have a center, we have a major axis, and we have a stunning graph. Okay, so again, if all we had to do was graph these, it's really simple. It's kind of finding all those the little details. The thing that's the hardest is probably finding the foci, not the hardest thing you're ever going to do. It just takes a little bit more work. Okay, so that's graphing these. Okay, so what we're going to do in the next video, we're going to look at what happens if we do have transformation. So what's going to happen there is the center is no longer going to be the origin. The center is going to be some ordered pair H comma K. Okay?